Okay, hi guys. Today we'll be looking at probability. It's a bit of a more complex topic than we're usually accustomed to. So we'll start with the basics of probability, the permutations and the combinations, and then we'll go all the way up to probability distributions. Okay, so the probability itself is defined as. So, what are the chances of something happening, considering that there are no restrictions or there are restrictions that will affect whether it happens or not? But it's a bit more technical than that. Okay, so when we look at probability, before we can determine the likelihood of something happening, we must determine the number of possibilities there are. Okay, so and these come under two terms. One is permutations, and the other is combinations. So permutations are an arrangement. Okay, so consider we have three letters A, B, and C, and how many possible ways can they be arranged? So let's say we have A, B, C, A, C, B, B, A, C, C, A, B, and it goes on and on. So overall, there are six possibilities in which we can rearrange A, B, and C, considering that all of these letters are used and the order matters. So ABC and ACB are two different possibilities. However, in combinations, when we have the three terms A, B, and C, there's only one possibility because the order doesn't matter as long as these three values are in the sequence. It's the only possibility that is available. So when we do the combination of this, the answer will only be one. But if we do the permutation of A, B, and C, and the order is taken into account, we'll get six, and overall with six possibilities of rearranging A, B, and C. So that is the distinct difference between permutations and combinations. In combinations, order doesn't matter. So I just explained one where we rearrange the three letters. So now let's go let's have a more technical look into permutations. So permutations where n, p, r, okay, n is the number of distinct objects, or all the elements involved. R is how many we want. How many we want. Okay, npr is equal to n factorial over n minus r factorial. Okay, so to understand this, first we have to understand what factorials are. Okay, let's say we have the number 5 and then we put a factorial over it. A factorial is essentially all the numbers that come before it multiplied together. So 5 factorial is 5 times 4 times 3 times 2 times 1. 20 factorial is 20 times 19 all the way to 1. All the way to 1. So all the numbers before it multiplied together. Okay. Now that leads us to this question over here. So this can also be used to determine the number of possibilities of rearranging something. So let's say we have okay, we have 5 objects. Okay, and we want to find the number of ways these 5 objects can be rearranged. So we can just drop in a 5 factorial. We don't need to use either permutations or combinations. Don't need to complicate it. We get a 5 factorial, so we'll easily get the answer that 5 times 4, 20, 60, 120. So 120 possibilities of rearranging these 5 objects. if we just use the factorial. You have 20 objects, we do it for 20 factorial. So this exclamation mark is the factorial and can be found on your calculator. So the question we presented to is, so let's say there are 3 vectors. How many 2-letter words, how many combinations of 2, how many I don't know, possibilities of 2 letters can be formed. So since n is 3 and we only want 2 letters, r becomes 2. So when we put it back into the main equation, 3p2 is equal to 3 factorial over 3 minus 2 factorial. Okay, 3 factorial is 3 times 2 times 1. 3 minus 2 is 1 factorial. So there are no integers before 1 because 0 is excluded from factorials. So 1 factorial is 1 and 3 times 2 times 1 is 6. So we have 6 over 1. So there are exactly 6 ways we can rearrange these 3 letters to form combinations of 2 letters, considering that order matters. But it's not always as easy as this. But if we have more interesting scenarios such as this, so we have a lottery, okay, with 20 tickets. Okay, so 2 lottery tickets are drawn. 2 tickets are drawn. So first prize and second prize. So how many possibilities? So let's say there are 20 objects, 20 tickets, they go on, and we choose 2 from this. Okay, so in all this we choose 2, and within these 2 the order matters. Whichever first is and whichever second is, the order matters within the 2 we choose. So there are exactly 2 conditions here. 2 are chosen, and in the 2 we choose, we have to take into account the order in which they are chosen. So in this scenario we use permutations. So first step, identify the number of elements involved, which is 20. How many we want? We want 2. So we have 20 p2. So out of 20 we take 2, and the p indicates that the order matters. Okay, so we have 20 factorial over 20 minus 2 factorial. Okay, 20 factorial minus over 18 factorial. If you use the calculator, you get the answer straight away, which is 380. But what I prefer to do usually, when if you want to shorten your steps instead of using a calculator, you can split up the factorial, because the base logic is it's a multiplication of all the numbers that come before it, right? So we can just put 20 times 19 times 18 factorial over 18 factorial, and you cut the 18 factorial up and down, because you split 20 factorial into these 3 elements. So 20 times 19, you still get 380. Okay, so this is a scenario where permutations can be used. In the next video, I hope to be discussing the specific use of combinations, and then we'll move on to probability distributions and stuff. Thank you.